Welcome to Chapter 5, Object-Oriented Programming. Chapter 5A, Class Design. Lecture 5, Classes and Objects. So we continue to teach different programming paradigm. Last time we had imperative programming paradigm, and today we are going to cover the object-oriented programming paradigm. And we will talk about class design first. This one is in Lecture 5, Class Design and Objects. So we'll talk about classes, derived classes, and use of classes and objects, and also static class instance attributes. Okay, these are for Python only, and also magic functions. So one thing I have to say that the best language to teach object-oriented programming is not Python. It is Java. Java actually describe the object-oriented programming way better than Python. Okay, way better than Python. But Python is a good language for teaching the overall concept for programming languages because Python have everything, and it is like C++. Almost every programming feature it has it. And Python also is a scripting language and is on top of C core or C++ core. So a lot of feature is very similar to the C++ core language. So overview of object-oriented programming. First, abstraction. So there are three major factors in object-oriented programming. That is encapsulation, inheritance, and polymorphism. Okay. Okay. And encapsulation, sometimes with data abstraction, they are very close. Okay. And also information hiding, they are very close. So abstraction is to use a simple idea or concept to reduce the complexity of the details. Okay, so that's called abstraction. And you have program abstraction and data abstraction. So object-oriented programming and using of the classes, it belongs to data abstraction. And function design, procedural design, module design, they are procedural abstraction. There are two types of abstraction when we talk about abstraction. Okay, and encapsulation and the class and object design, this is data abstraction. And because we encapsulate the data, so also has an effect of the information hiding. So the word data abstraction, information hiding, and the data encapsulation, they are very close. But if we are asked for three major factors in object-oriented programming, that would be encapsulation, inheritance, and the polymorphism. So encapsulation actually is information hiding. You do have the data abstraction, keep your private data and the public methods for people to access it as encapsulation. Encapsulation is for data abstraction. Then polymorphism is, and then the inheritance is describing the class-to-class relationship, is a relationship. And there also has a relationship. So basically, these are two class-to-class relationships that we talk about. And polymorphism is the concept for polymorphism. Basically, in object-oriented programming, we have the inclusion polymorphism that is using the superclass as the inclusion polymorphism. And we also have the so-called parametric polymorphism, that's generic programming, and also coercion polymorphism and the ad hoc polymorphism. There are four types of polymorphism. But here, when we talk about object-oriented programming, it is the inclusion polymorphism that using the class, superclass as abstraction, and then you group different classes together. So all these topics, we will discuss it in our object-oriented programming courses. And this is chapter 5A. 5A. Chapter 5A is on the class design. 5B would be class-to-class relationship, including is A and has A. Okay, that's class B. Class A is for class design. Class B is A has A, and talking about interface, object class, duck typing. Okay, those kind of the issue that happen in inheritance and polymorphism. And when we talk about data encapsulation and data encapsulation and data abstraction is in 5A. Okay, so that's the two chapters we will be covering. And right here we have data abstraction and program abstraction. So data abstraction is use a container to contain the data inside the container. So it is also one way of doing data abstraction. So in a way, array is also data abstraction because you kind of group the data of the same kind into one array. Okay, so that and string is also data abstraction. Okay, and then you can actually hide your data from the user. So that is one kind of the data abstraction. And data encapsulation usually happen on object-oriented programming. Okay, and data abstraction might include enum or array or any reference type that actually is part of the data abstraction. Information hiding depends on whether you use the data hiding, information hiding techniques such as the private data and public methods. So for example, C++ language is a structure. Everything is public. So it is object-oriented type of design. Yes. It is data abstraction. Yes. But it's not information hiding because everything is actually public in the structure of the C++ language. So right here, this three terms not exactly the same, but very close. So object-oriented programming, we do have class and object. Before we talk about class, we need to know about object first. So object is a data entity that has method associated with it. Okay, associated with it. So that's called object. And class is used to generate the object. So class is a template. Class is a template that we use to generate the object. But sometimes you also have a meta class. And your meta class is used to generate your class. So in Python, we do have two levels of the abstraction, two levels of the class abstraction, but it is different from Java, okay? But it doesn't support the mix-in inheritance. It doesn't actually support that, okay? So here actually different language do support different way of doing object-oriented programming. So in this chapter, we use the Python's way mainly, okay? So Python's way do have class and meta class. So meta class is a template for class, and class is a template for object. And object will be instantiated with different data and procedure inside the object. So this is what we say object-oriented programming. So object-oriented programming feature, we have this different one, and as I said, the most important factor are these three, okay? But in this chapter, we are going to cover the class design issue, so including class object abstraction, encapsulation, reusability, okay? These are something we talk about in this object-oriented programming. Message passing, polymorphism, inheritance. Okay, message passing, actually, you can consider is also part of the behavior. Okay, behavior. So actually, it's related to the object methods. Okay, object methods. And these two are more related to the class-to-class relationship. So that's what we will be covering. Okay, these are different topics. Okay, there's a lot of different topics, and this one we created basically based on the Java language, but it applies to many other languages as well. So these are different topics for OOP, and right here I do not go into each individual one, but when we need to do review, I will bring this one up. And next one, object-oriented programming. Okay, so we will talk about data abstraction, some back in the union and naming and the scoping. Okay, so in previous chapter we do talk about it a little bit. Okay, and then basic has the static set available, and then function has static and locals, and then modular 2 has the modular and type, module types. Okay, so in a way, the data abstractions technique is keep improving until object. So when object-oriented programming came out, it became the dominating way of doing data abstraction. But before that, we do have different way of doing it, providing the module. Okay, so there are certain times that module programming is very important, and before that, we only have the local and static section. Okay, so these are the development of different data abstraction stages. Okay, so static allows subroutine to retain the value from one to the next call. Okay, so that's called static. And static can be class static or method static. So class static in Java language, we do have class static variable, and that is class variable. So no matter you have object or not, the class owns some data. It's called class static. And function static is a static variable that only when you call some certain function, you get a static. So that is a special feature in the C++ language. Okay, and right here we talk about everything belong to the Python language. Okay, and Python language in class there is static variable, static methods, but in Python we do not have the static variable in general. Okay, we do not. And we have module that allow collection of subroutine to share some static. Okay, so that module is a content compartment, and you have a few subroutine and static variable over there. So that's called module. A module later developed into the class. Okay, into the class. A module, some people also call, some language also call it a namespace. Okay, for example, both C++ and Python, the module called namespace. In fact, C++ also have module, but it's not too popular, and that's we do use the namespace more often. So object-oriented programming, module type allow the module to be object data type. You can declare a bunch of them. This is generally intuitive. It avoids explicit object parameter to many operations. Okay, in C++, you need to make the classes friend of the other. This is called friend function. Okay, this is called friend function, and friend function can be operated like a substatic function. Okay, so this one is a special feature for the C++ language. Okay. And module type allow the module to be abstract data type, and you can declare a bunch of them. So this one is a special feature. Okay, special feature. So it's available in modular 2, but in general nowadays not a lot of people using it. Object-oriented programming, object inheritance and dynamic method type binding. Okay. Later. So this dynamic binding method binding is available in Java, and we call it polymorphism. Okay, so this become more mature for OOP. Okay, moving from module going to OOP, these two features being used. Okay, so then after that we do start to have these three major factors. So before Java age, okay, before OOP, we actually have more of the encapsulation up to module, and after that when object being introduced, inheritance and polymorphism become very popular. So nowadays, most of the language still be supporting OOP first. Okay. Class and object. Before we looking into the class definition, let's look at class and object. And object is a concept. Okay. We do have Python language that is a useful, simple script numerical computation, and it supports the basic structure programming. So it is an imperative programming language, and you do have all the structure programming feature for loop, if then else, and functions. And it also supports object-oriented programming. So this chapter, we are going to look at this, the object-oriented programming issue. And it also supports a functional programming feature. So basically, Python supports quite a lot of features. That's why we picked Python language as our main topic to discuss the different design paradigms. Okay, and right here we focus on the objects. We focus on object. So object is a concept. Okay, object is really a concept. It is a concept that you have the data and methods putting together. Okay, so the concept of the object, you may use a dictionary to represent it. Okay, in Python, you can use a dictionary to represent it, and you can basically using the JSON, JSON file to describe it. Okay, and you can also use class to define it. Okay, so let's look at the difference. So an object is a collection of data field and its associated methods. So what is a class? Okay. Before we go into the class, let's look at what is object. Okay, what is object? So here, let me create a function, a file called object1.py. Okay, so this one I can create a dictionary called obj. Okay, it is a dictionary. So here we do put this value in here. We do have a x. Okay, equals 3. Okay, we do put a y. Okay, equals 4. We do use a function that's called distance, and let's use the function called f. Okay, so this f function is undefined. So right here, let me define a function called define function f. Okay, this one I will actually get a certain object. Okay, certain object to it. Okay, so here I'll get certain object to calculate it. So here I'm going to get certain parameter. Okay, certain parameter to do it. Okay, so here I may have a x and y, and this one I'm going to actually do import. Okay, mass. Okay, and this one I'm going to return here. Return. Okay, mass the square root of my x times x plus y times y. This is the distance between the point to the origin. Okay, to the origin of the coordinate system. Okay, so we got that. Okay, we got that. So here, this one we may have the point P. Okay, point P, and this one we had a point P. This one we can change it to P's x value star square, and then P's y's value. Okay, so something like that. Okay, so let's do this. Okay, so let's do this. You will call this one and you pass this over. Okay, so now let's do this one. We have this, let's print objects. Okay, so x value, objects x value. Okay, print objects y value. Okay, print this too. Let's try this one. There is no x, so let me use different way. Okay, let's do using the It's not JavaScript, okay? JavaScript allows this, but Python doesn't allow it. So let's use the dictionary as a way to describe it, okay? Dictionary ways to describe it. So we save this one, we run it, okay? So you get a 3 and 4, okay? Next one, we do use print, okay? The OBJ's distance. Okay, so this one apparently would get the f function, okay? So f function, you will call something and we will pass the obj into it, okay? We will pass the obj into it, okay? So that's that. That actually will save and we'll run it, okay? Okay, and you got the distance. So this one, it can show you that you have the data and data, okay, x data, y data, and the member function, okay? And you can pretty much pass the function, pass the data to there, okay? You can pass the data to there. So you call the function f, okay? And you put the p there. You can also put your sy there, okay? Put your sy there. You make it a function call, okay? So let's try that. Let's try this one. Let's use put my obj's x, okay? And also obj's y's value, okay? So there's a function we put in. This one put in x, okay, and the y, okay. So here let's do x and y star square, okay. That is the obj. Obj is current value, okay. Current value. I mean, I'm sorry, this one probably not, okay. So this one probably not going to work. So it's okay. We put our f function, okay. We put our f function, and here let's put in the point p, okay. And we can do x value is y's value, okay. So this one will be an example for using the dictionary for object-oriented programming, and you can upload a object from the JSON file and then do it, but that's beyond our scope right here, okay. So that is a object, and class is a template, okay. Class is a template. So what we talk about here for the object, it is a pure object, but we cannot use this one as a template. So we would need to have a class for it. So class is a template. So to represent an object is easy. You can use dictionary to represent it. But if you want to really make it reusable, then you may need to have a class. So this class, let's actually call it a point. And this one, if you put nothing, it will be the same as you put a object here for inheritance, okay? But we don't need that. We just do this, okay? As a default class, you will inherit, okay? So here you set up this. This is the constructor, okay? Constructor, and you put your x and y. These are 2 parameters. And self.x, okay, this one create a instance data field, okay. So self.y, this create another instance data field. So this point has 2 values, x and y, okay. So that is x and y. And that's actually try to have another one. So here we have definition of the str, okay, and we have self, okay. This one actually will return string of this format, %d, %d, okay. So we do percentage and then self.x and the self.y, okay. So basically, you print out the data, okay. You print out the data using the formatted string. You replace this one with this one with this, okay. That's formatted string. So with this two, you are able to create a point p equals point, Okay, this one equals point of 0, 0. Okay, and then we can print P. Okay, we can print P. Let's save. Okay. Okay, sometimes we want to have the no argument constructor, so we can put this one equal 0, put this one equal 0 for the default value. For the default value, so right here we don't have any data, and we actually just use the default value for x and y. Okay, we use the default value for x and y, and then we should be able to create an object, and both x and y are 0, so we can use this one using the default constructor. Okay, and default constructor is the default value or the parameter, and default value are both assigned to be 0. So right here we can have a p1 equals point of 3 and 4, and we do print my p. Okay, p1. Okay, print my p1. So that is another point called p1. Okay. So this one create a simple class, and class is template, so you can duplicate the object, okay, using the class. But object, if you use it using the dictionary format, you cannot basically duplicate it like a class. But it do have one advantage, that you can do object of the G, okay, object of the G will be equals 3, okay. Then you do print, okay. This one we have the so-called object, okay, object's G value, okay. So using dictionary, okay, using dictionary, we can arbitrarily add a new data field. Okay, so it's also be flexible in a way that you can add some data field into it very easily. So at this moment, we print out the object. Okay, you will have one more data field. Okay, you will have one more data field. Okay, you have one more data field. Z equals 3. Okay, that's the object we have. So that's the difference between object. So object is representation of the data, okay, and it has the data field name and the value brand and values, and sometimes you can put a function into there as well, okay. And class is actually a template to generate the objects, okay. Class is template to generate the object. So we need the class because we can create an object in a short time, okay? So that's the class, okay? So the object you can create. So object basically, each object has the ID, value, and the type, okay? 3 things you need to look at. So if you do dir, it will show you the strings features, okay? String features. And it has some function you can call, convert it to lowercase or convert it to uppercase. Okay, these are the methods associated with it. Okay, and then class and type. Each class has some type. Okay, each object may have type. So using type function, you can check the type of that object. Okay, you can check the type of that object. So right here, even this dictionary, we can print out the type of the object. So OBJ, the dictionary is really a object, okay? So you print out and it will show you it is a class dictionary object, okay? It is a class dictionary object. Okay, it's a class dictionary object. Okay, so let's continue. So that's something you can do. So each object, let's see here, okay. So each object will have some attribute and property and some methods, okay. And in object-oriented programming, our main topic would be the encapsulation, okay. Encapsulation is putting your data and the method into a class, that including the private data and public methods. Okay, that's encapsulation. But sometimes in Python, we really don't put those data fields as private. Okay, sometimes it's harder to use using private. Okay, so it depends on whether you have high concern about the data field or not. Okay, and then you have inheritance and polymorphism. Inheritance is to create some specialized subclasses. Okay, polymorphism is to make some code reusable and also make some code to be customizable. Okay, so actually that's the polymorphism. So now let's look at the class design. Okay, so class design, we can define a class. Okay, so define a class is to use a class statement with class name, okay? And you put a few statement there. So we have already defined a point class for you, okay? And we define a class, and we can use some of the document string over there. So let's look at document string. So this one, in order to save time, I'm not going to waste time for typing. So I'm going to get some document string from some previous point class. Okay, so let me copy this string over to my point two. So you put a triple quote document string over here, and that is a document string. So here, when we do print, okay, print the P, okay, P is object that actually document string, okay. Here the call it using the point. Okay, it's a point class document string. Okay, so document string is here. We call it doc string. Okay, it defined here. So this one, whenever you use this one called document string. Okay, let me cut it. Okay, put it over here. Okay, put it over here. Okay, so here let's do print type of the P. Okay, let's print the dir of the P. Okay, let's make sure that we have printed enough information for it. Okay. Okay, so right here we do print out the P. Okay, type of P is actually is point class. Okay, and directory it will give you the different attributes belonging to that object. Okay, and then we print out the document string. It will print out this portion, and this portion is exactly the string we put it over here. Okay, this is called document string. So when you use the help in the console, so let's try that. Okay, let's try Python. Okay, and here we get into Python and we import. Okay, object2.py. Okay, we import object2.py, and you can see that it's a document string being saved over here. Okay, okay, so okay, I'm sorry. Okay, so let's do import object2. Okay, without py. Okay. And then here, we do have this object2 being imported. Okay, so let's do print. Okay, the object. I'm sorry. Let's try different one. Let's try help. Okay, help object2. Okay, so help object2. It will get the name of object2. Okay, the class. Okay. And you would do point coordinate. So this one is shown in our, these are the so-called document string that we actually, if we look at our code here, okay, okay, our code over here, okay, so that's that, okay, that's that. Okay, anyway, that's when you use the console, okay, Python console, to look at the document string using the help function. Okay. Okay, so that's a document string, and we finish the document string. And you can define a class. Okay, so define a class you can put a document string. You can also declare a variable. And the variable is considered to be a local variable to the class. So if you access the local variable to the class, you can use class name that employee. So sometimes you can also use this one as the class variable, okay, as a class variable. So every time you call the class name that this number, you will get to this data field, okay, as a class variable. So class variable usually is used for share property. So for example, in this case, that it doesn't belong to any employee, but we do need to calculate how many employees have been created in this class. So every time we run the constructor, we will increase the employee count by 1. Okay, so this one is a share property. So basically, the class define the employee, and every time you can create employee 1, employee 2, and employee 3. Okay, but the number of employee is kept into the class. Okay, so this one is a class variable called employee. Okay, this one is a class variable. Okay, number of employee is a class variable, and when you use it, you have to use a class name that the variable name. Okay. So init function is like constructor, and self is similar to the this in Java. Okay, it's talking about current object. Okay, so usually self we put into the first parameter for some function, then that will become a instance function. So right here we have an instance function of the string init. Okay, so right here we can also define a getter function. Okay, so get function get a self. Okay, get function. So this get function is called get x. Okay, get x. So this one we will return a self.x. Okay, so same thing we can use define get y function self. Okay, and this one will return self.y. Okay, and we do define set x function. Okay, we do define this one. We will actually assign self.x. Okay, need to have one outside value x. Okay, so we put that x from outside to myself's x. Okay, and that is setter. So define set y value and then is. So your self-reference should be put always the first parameter of your instance functions. Okay, instance function. Class function, you don't need that, okay? But instance function, you do need. So these are the getter and setter for my point class. Okay, so right here, let's try. Okay, let's try. Let's try over here. Okay, so print. Okay. Okay, these are getter and setter function. Okay. These are getter and setter function. Okay, getter and setter function. Okay, we'll get the right result. Let's go back. Okay, these are getter and setter function. Okay, and here we can create a instance. Okay, we can create instance using the class constructor. Okay. And there are a few functions you may be interested. It's a document. Okay, dictionary is the properties. It's a dictionary that contains all the properties. Doc is the documentation. Okay, of put it into docstring, and the class name and module and also basis. Okay, so let's try this different one. Okay, these are different class attributes. So let's try this different one. So here, let's go back to the program. Okay, so here let's do print. Okay, point that and then another dictionary. Okay, point, okay, point that under the name, okay. So the name of the, let me see. That's the name of the class, okay. And we do use point, okay, point that, and then our module, okay. And point, okay, point that under the underline basis. Basis are the base classes that the point inherit, okay. So we do get, okay, this one is the dictionary. Okay, this one is the so-called dictionary, okay. And the dark string is over here, okay. And the name is point. And the module is currently main function that contain it, okay. And then the last one is the basis. The base is the object. It's a tuple, okay. Tuple object class is its base, okay. Okay, let's continue. That's the different class attribute. So this attribute belong to the point class, okay. It doesn't belong to the object, okay. And you can destroy the object using delete, okay. You can delete a object, okay. So that one, let's assume that we do have right here, okay. Let's create a point Q equals point, okay, 10, 10, okay, 10, 10. So then we print my Q, okay. And then after that, we do delete the Q, okay. And we print my Q one more time, okay. We print my Q one more time. So first it is created, and then it actually being destroyed, okay. So when we create it, we print it is 10, 10. After we delete it, we try to print it again. We lost it, okay. So that's that. So here we can also define another function for define underline reprint, okay. Reprint is a representation of this object, okay. And this one we can return also a string, okay. We also a string. So right here, okay, we put it over here, okay. So this one actually let's use it for this, okay. This one is called representation, okay. This one is called representation. Representation sometimes is similar to the string function, okay. Both are sometimes, but string function is more powerful. When you have string function defined, use your reprint, somewhere you can use representation will be override by it, okay. So that's assume that we do not have the string function, okay. We do not have a string function. So let's actually save and then run it one more time. So it become angle bracket, angle bracket, angle bracket, okay. So now if I turn on my string function, we kind of change it back to the parentheses, okay. So this is the relationship. Representation sometimes can replace a string function. In some location, maybe not, okay. So you, in some situation, not, okay. And you have to, and also string may be stronger than the representation, okay. Okay, so that's the some default function we can do, okay. Object collection. And okay, before we leave in for the atomic and the molecule, okay, before we go into here, okay, that's actually finish another one. So here we do have the getter, setter, and constructor, and the toString function. In Java, we also have some function that's very important. Is the equality check. Equality check in here we do have equals, and we have self function, and this one return, okay. You need to compare to another object, okay. Another object. So this object, let's call it other, okay. So this other, okay. So if, okay, the type of the other, okay, if it's not equals my type, that's a point type, okay. It's not a point type object. In this case, we do not need to compare them. So here we will return false. Okay, if the other object is not a point class object. Okay, otherwise our self.x will be comparing to other.x. Okay, and the self.y will be equals to other.y. Okay, so this is equality check. Okay, this is equality check. So that's actually don't print it. Okay, don't print it because I want the program to continue. So now I do create something called PQR. So R object is point. Let me use the same value. Okay, so 3, 4. Okay, 3, 4. So that's actually print R. Okay, P1 equals R. Okay. So this one is equality check. Okay, equality check, and we can also try to compare the print. Okay. P1 equals some object. Okay. This one I use a tuple. Okay, so this tuple is 3 tuple. Okay, a single element 3 tuple. Okay. I just try to find something that's not point object. So it's false. Okay. So let's put 3 and 4 in there for comparison. Okay. So we see even though it's a tuple but it's different type. Okay. We are trying to represent point using tuple and class object. They are not the same. Okay, they're not the same. So you get a false. Okay, you get a false. Okay, so that's the equality check. Okay, so then we have the basic elements. Okay, basic properties that usually we would define a class, including the constructor, getter, setter, equality, and toString. Okay, that is what we usually see in the define of a class. Okay, next one we do look into the atom class and also the molecule class. We're going to look into these for different class and the example of class and container. Okay, so let's actually get. Okay, let's actually save this one. Okay, let me go to my here. Let me open a folder. Okay, this folder. Let me go to here. Go to my demo program in chapter 5. Okay, you can download this one. Okay, you can download this one. Okay, from internet. So right here, I'm going to look into the atom.py. So atom has an atom number to symbol list, and there's an atom class. So each atom has its atom number and also the location of the atom SYG. Okay, so you put your atom number into the instance variable atom number and then SYG as a tuple to the position. Okay, and then if you get a symbol, you will use an atom number to refer to this atom number to symbol. Okay, so that's the symbol, and we can actually print out your atom. Okay, when you print out the atom. So here we create a carbon atom with location SYG like this. Okay, and we print out the atom and then get the atom's symbol. Okay, so let's run it. Okay, so this one we get the carbon, that's number 6. Okay, symbol is C. Okay, so that's atom class. Okay. Okay, next one, let's continue. That's atom class. Okay, and atom class has a overloading the default constructor. Okay, and we also print it. So now here we do have the molecule class. So molecule actually has a name. Okay, name it was default set to generic. So name equals generic is default value equals generic. Okay, and we can assign a new name for it. Okay, if you do not assign parameter, you'll get generic. and you will have a atom list, and you can add different atom into your molecule. So your water, you have H2O, so you need to add your water H into there, 2H and 1O into there, okay? And you print out your molecule as well, okay? So this one, I mean, look at the molecule, the PY. So this one, okay, we create a molecule called water. So water is a name for the molecule. And then we put a oxygen, okay, and we actually put the oxygen there, and we add 2 hydrogen, and we print out a hot molecule, okay. So this one, we do get this, okay, this, okay. So this is a molecule named water, okay, and it has 3 atoms, okay, it has 3 atoms. So right here, I'm missing a T, okay, sorry for that. So let me save it, okay. I'm missing the T. Okay, you get this, okay, you get this. Okay, so this one's a molecule. So this molecule is a container. So you put, there's a name and there's a list for that molecule, okay, and you put several atoms into it, okay. Okay, that's fine. So let's continue, okay. So class and classes and their use, okay. So usually your class has several applications. You can use class for different way, okay. You can use a class for different way. Usually you can use a class as a main application program, and then the whole different functions, okay. And you can use a class as a utility class, okay. You can actually use a class for helper class, okay. So the one we declare the point class is a data class, okay. It is a data class, okay. And then you can make some class as utility class. So usually like math module or math class, it is a utility class. It only provides you a lot of different functions to use, okay. Program class sometimes is, you have main program, you can call different smaller program module, okay. And runnable is a class that can be run, okay. Runnable is a class that can be run, okay. And we do have the object class or interface in Java, but in Python we do not have it. We can mimic their function, but we do not have these 2 things, okay. And runnable class is a class that you can run, okay. You can run because runnable class. So namespace, okay. Class is a namespace in module. So you have this my function, it creates its own namespace, okay. So my function that is exponent of 1, you actually will call this one, okay. You call this one, you get 0, okay. Okay, class can be a utility function, so you can provide a lot of method, and you can actually import only the function for people to use, okay. So usually math class or random class, you do want to import some function from there sometime, okay. That's utility class. Data class, data class is a template to generate the object. So like the doc class, okay. Doc class can create object called rain, okay. And there's a base class, you have the color, okay, a method, okay. And the data class, you can assign the property to it, okay. That's data class. And some class can also be used for callable, okay. You can use for testing, like unit test module, okay. And runner is a class you can run, okay. So this one, we don't touch this one, maybe later, sometime later, okay. Okay, next one, class variable and instance variable. So class variable, you actually put into the over here, okay. And instance variable, you use a self. Self means current object, okay. So something like that. That's the difference between class variable and instance variable, okay. And here you do have a overall total, that's a counter, that is a class variable, okay. And here my total, this one is instance variable, okay. So we have this class, and we do create a is a counter. Okay, B is also a counter. So A that increase, so A's counter will increase the overall counter and also self counter. Okay, and B's increment, so B will increase the overall counter and also B's total. Okay, and so we after we increase A one time, B two time, and then A's my total is 1. A's class over total, that is what? That actually is 3. Okay. B's my total is 2. Okay. B's class overall total is 3. So overall total is a share variable. We call it the class variable. Here you can see actually you need to put the class name over there. Okay. You need to put the class name over there. So this one is actually put into the our class. Okay, so let's actually go back to my folder. Okay, go back to my folder. Go back to my demo folder. Okay, so use this one. So let me pick up my object 2. So the object 2 here we have here. Okay, so let me create something called numbers. Okay, so that is numbers equals 0. Okay, so whenever we call the constructor, we do increase my numbers. Okay, will be increased by 1. Okay, so here at the very end of the program, let's print out number of points. Okay. Numbers. We create 4 numbers. Okay, we create 4 numbers. So we have P, P1, Q, R. Okay, 4 numbers. 4 points. Okay, 4 points. Okay, that's the use of the share variable or class variable. Okay, so class scope. Okay. So class scope, okay, class is actually a module, so it also has its own scope, okay. So they are global variables such as a total simple, that's defined outside the class, okay, that's global variable. Class variable is the employee count that's inside the class, okay, inside the class, usually not in the function, not in the function, okay. Inside variable, you have a cell, okay. So it's global here. Class variable here, and inside you define of the underline init, you have cell. When you have a cell, that's instant variable. Okay. Okay, this one we will skip. Okay. And person, I think it's fine. We don't. You can study it. Okay. Instant attribute. So instant attribute is your data field. Okay, your data field. So instant variables such as a name, surname, birthplace, birthday, address, telephone. These you pass the parameter and you assign it to self that this is the instance variable. Okay, so inside the class, everywhere you need to use the self reference for the instance variable. Okay, init function is to create a object. Okay, okay, usually to initialize the whole object. Okay, here we have private and public attribute. Okay, so this one underline, you create a private variable. Okay, you create a private variable. So that's actually go back to our point class and let's create a private variable. So this private variable, let's call it that. Okay, underline. Okay, this one let's use actually call it nickname. Okay, it's called nickname. So this nickname that's actually is a private variable. Okay, it's a private variable. So this one, let's call it location. So right, it's a private variable. So here, if right here, I'm going to use define. Okay, a display. Okay, display. Okay, still okay. So here I'm going to pull in my that's a private function. Okay, so private data. So print cell that then the name. Okay, we print another name. Okay, so here outside. Okay, let's try outside. Try outside. We do have this one called p. Okay, let's pull in. Okay, that's actually p dot display. Okay, and we can also do pull in. Okay, p dot underline. Okay, so these are private variable. Okay, so that's actually save all. Okay, save all, and that's wrong. Okay. So when we run it, okay, let's see. Okay, if new name is location, okay, new name is location. When we use the so-called display, but when we use using the instance that new name, it's a private attribute, so you're not supposed to be able to print it. So this is not okay. Because underline is a private variable, so you don't get it. Okay. So here we have the attribute and we use the decorator. So at this moment we don't touch the decorator. Okay. So maybe sometime later. Okay. So double underline is for private data field. Okay. Private data field. Private data field, we use a double underline. Okay. And then single underline. So double, this is private. These are private variables. Single underline is protected. Okay. Other without underline, they are public. Okay, they are public. So these are the visibility of Python's variables. Okay, these are visibility of Python's variables. So single underline A, this is protected. Okay, this is so-called protected variables. Okay, so right here, we don't go into the detail for this different definition. So you may have default accessor using get attribute. So get attributes for certain object and attribute name. Okay, you can use the default built-in get attribute. Okay, and you can also use built-in set attribute and built-in has attribute. Okay, so let's try this 3 over here. Okay, so go back to here. We should be able to do okay, and then p. Okay, this actually is get attribute of the p objects. Okay, the attribute name is actually called x. Okay, okay, set attribute. Okay, this one we don't need to print. Okay, we don't need to print. We do set attribute with p object. Okay, and then we set its y value. Okay, and set it with 100. Okay, then after that we do print my p. Okay. Okay, then the other one check has attribute. We don't need to check. Okay. Okay, so this one actually is the result. Okay, so that is your setter and getter using the built-in functions. Okay, using the built-in functions. Class attribute. Okay, class attribute, you have the class data and class methods. Okay, class data and class methods. So here you do have put the variable here, they are class variable, okay? So when you want to use it, you have to use person.titles to access. So if you use a self.title, you try to use this one, no, you don't do it, you don't get it, okay? Because self is current reference, okay? I'm sorry, actually, you use the self.title, you can still use it, okay? Because it's your class name that the class name that title is using the class variables access way. But class variable can also be referenced by instance. So you use a self.title, that should still be okay. Okay, that is should still be okay. So in Python, there's no real constant because they don't allow, okay, but you can mimic it, okay? You mean using O capital to mimic it. And access of the attribute, you can use, so the class attribute, you can use the object to use it. You can also use the class to access it, okay? But instance variable, you cannot use the class to access it, okay? Okay, so here, instance variable overriding the class variable. So if you have these and these, okay, class variable use a constant, okay, it's a default value. So when you do person.disease, you will access the instance variable, okay? Even though you can use a object to access the class variable, but if you define both of them using the same name, when you do a object that the data field, you will get its instance copy, not the class copy. Okay, so you can look at the demo program, okay, and then try to avoid the side effects. Okay, try to avoid the side effects. Okay, so these are some basic definition for the classes. Now we are going to talk about methods, and methods and functions, they have similar definition. So when we talk about object-oriented programming feature, we have different objects, and there is a feature called message passing. So message passing in the old day is between two objects. You pass the message to the other. And this one actually is current method. Okay, we call method because we call it method or behavior. Okay, behavior. Okay, so in the old day, people call it message passing because you pass a message and then the other object will take action based on the action that you send, the message you send from different object. So it's actually related to the behavior of a object. And in object-oriented programming, we also call it a method. Okay, so method is actually instance function. Okay, a function that belongs to an instance. But because we also had a name static method, okay, static method. So it's a method that existing that without creating any instance. So this method right now, you can look at it as the same as function. You can also call it the method for the object-oriented programming, and it is related to the behavior of a object. So static method. So static method is a function that have no argument nested inside the class. So work with the class attribute and not instance attributes. So you actually use the class name that method to call it, okay? And you can use the built-in function static method to create them, okay? So this is one way you create them, and let's look at the example. So here I'm going to create another one. We are going to create another one. Let's call it ticker rate. Okay, one.py. Okay. So this one that actually to import mass, okay, in case that we need it. So we have a class point. This point class is a class that we have developed before. So that's actually define the init function. Okay, and we have self, and then we have x and y. Okay, and this one, let's actually look at this one. Let's actually look at the data self.x equals x, okay, self.y equals y, okay. So we can set them to be 0 and 0 for default values. Okay, so now I need to define a function for conversion to string. Okay, this one is for conversion to string, and we will return it's a point, so let's return these. Okay, percentage d, percentage d. Okay, percentage self.x and self.y. Okay, so that is a formatted string. So with this, we can create a point p equals point. That's the constructor. And we put no data there. Okay, this one will create a point which the x and y both are 0. So we save it and we run it. Okay, so this one you got a point of 0, 0. Okay, so this one we got it. Now we may have a function. Okay, over here we can define a function over here. So let's define a function over here. Define this function. Let's get the point. So let's get a function called length. Okay, length function. So this length function, actually, let's make it let's make it a class function. So let's get a point, and we are going to calculate the data of the point. Okay, so here let's get a point p. Okay, point p, and we are going to get that point's x and y value, and then calculate it. Okay, so this one we will make it a class function. So here we will return. Okay, let's see. We have x and y, and we'll return self p dot x times p dot x. Okay, plus p dot y times p dot y. Okay, so this one is a function. So we do mass dot sqrt to find the square root of this one. That's a points value. So this one p is a parameter. It's a local value. This p is a global point. Okay, these are two are different. So now let's calculate the distance, the length. So L. Okay, let's call it this one. We call it norm. Okay, now let's call it norm. Norm p. Okay, norm p. Point p is a norm. Will be equals the length of the point p. Okay, and then okay, and this one we cannot find a function, so we would use the point class. Okay, point class and the name of the length, and this one is a class method. Okay, it's a static method. Okay, static method, and then it is used as a utility methods to help other people any point to calculate the length. So this one, that's pulling my norm of p. Okay, okay, like that. Okay, and this one we save and we run it, and we get 0.0. Okay, so let's get another point. So here, let's get another point. You will get 0.1 equals point of the 3 and 4. And here, that's actually get this one, 0.1's length. Okay, just save it and run. So if I don't have the class, don't make it a static function, we still can do it. Okay, we can still use a class name that length to run this length function, okay? But we can also officially make it a static function. So here, right here, we can call this one length equals static method, and then put the method there. Okay, this one actually is this static function, static method is a function, okay, function factory, okay. So it's a function, actually, in this case, it's a function factory. So what happened is like you have a function called length function. You put it into this function called static method, and you kind of transform that function to this as the output. So this one is output function, this one is input function, and it's the same function, okay, same function name. But after the process, this length function will be a static method. So we do this one, we save, and we run it. Okay, it's still the same static function. Okay, so this one is the definition of static function. You can do it this way, or you can put it as an internal function this way. Okay, and let's actually do. Let's do this one. Okay, let's do point. Okay, dir of the p. Okay, dir of the point p. So let's save this one and run it. Okay, so save this one and run it. We have class, we have differences here. Let's continue. So we do have a length over here. Okay, we do have a length over here. Okay, so let me take out this static function here. Okay, okay, so take out this static function here and let's run it. Okay, let's look at it. There's still a length over there. So there's pretty much no difference, okay? So this one is a static function. I run it by point the length. So here, I may also do it. So norm P2, okay, will be equals point, no, equal P the length. And I run P1, okay? So P is a object, okay? But that object owns a function called length. It is a static function, but static function can be run by what? Static function can be run by using the point, the class name that length. Okay, you can class name that function name. It can only be called by the object that the function name. Okay, these two ways is both okay. So here let me do print my norm true. Okay, let's look at this one. So we save and we run. And it is not instance function. So this one, P take one positional object, so it doesn't pass. It doesn't go through. It doesn't go through this way. So this way, it doesn't go through. So let me actually take this one, make it a static function. Okay. So previously, if we don't declare it as a static function, you can call it by class name the length. Okay. It passes. And it passes because it is a function defined in the point domain. So point the length, it will work. Okay. So use it as a class name that function, it works. But using the object the length, it doesn't work. Okay, it doesn't work. So this one is actually make this one available. Okay, and this one available. Let's do it one more time. So this time it works. This time it works. Okay. This time it works. So this time is a static function. So static function, you make this way, okay, make this way, it will make it as official static function. So your class name that function name and the object that function name both will work, okay. So class inner function, no. This one, yes, okay, yes. This both, yes, okay. And this one, we copy it here, okay. And this one, no, it's a class inner function. It's a class inner function. You can use a class that function to call it, but if you call it by using the instance, no, you cannot do that, okay. So, but static function will work, okay. So here, that's why you need to make it a static function. So, okay, that's the first example. Okay, that's the static function. Why we need static function? So static function, you declare it, and then there's no self argument, and it's usually used for class service routine, and you can make it to be run by class name dot function name or the object dot function name. Okay, so this is the way we create it. Okay. And there's another way we can create it using decorator. We will talk about it later. Okay, we'll talk about it later using the decorator to call it. Okay. Okay, so that's that. And then we do see this. Okay, so there is a print instance function. Okay, and that you can call it by class name. Okay. And the benefit of a static function, it localizes the function name in the class scope. Okay, it moves the function code closer to where it is used. Okay. Okay, so you get a local function you can use. Okay, and it allows subclass to customize the static method. So static method, when you declare it a static method, then the subclasses will also own it. So if you don't declare it, your subclasses may not be able to own it as well. Okay, so you can inherit a static function without redefining it. Class method. Okay, class method is similar to the so-called static function. You can also use the class method to build it. Okay, and this one is different from the static method. Okay, it's different from the static method. So here, okay, here we need to use class. Okay, we need to use class. So class method is the current class function. Okay, it's a current class function. So see here, we do have a function that's my method. Okay, my method. So you do a class method, you can call it. Okay, and its subclass can also call it. Your subclass can also call it. So the behavior of a class method make them suitable for data that differ in different class hierarchy. And actually, in the subclass, you can actually redefine it. Okay, you can redefine it. You can redefine it. Let's see here. Actually, let's do this one. Okay, let's actually create another one. This one, let's call it decorate 2.py. Okay, decorate 2.py. So here I'm going to copy the whole thing about class. Okay, copy the whole thing about class. Copy to decorate 2. Okay, so right now I have a length. Okay, I have a length, and this one I have a point class. So here I will define another class. Okay, let's call it location class. The base class is this one point. Okay, and here we have the instance data. Okay, we have the instance data. So right here I'm going to define. Okay, and then init function. Okay, init function for it, and I will have cell. Okay, and we have the x equals 0. Okay, let's do lx equals 0 and ly equals 0. Okay, I just try to create a difference between point and super allocation class. So here I do call super. Okay, super dot init. Okay, that's calling the init function. Okay, here. Okay, so I'm going to pass by ls and ly over here. Okay, that's actually a subclass of the point class. Here's subclass of the point class. So right here, let me call it P1. Okay, P1 equals location of the location of tutu. Because we already have some function we can use. Okay, so right here, let me actually do this one. There's a length function. Okay, there's a length function over there already, so we can do this one. It's a static function, so we can do len. Okay, p1 equals p1 at. Okay, it's a service routine, so we actually do use this one called location that. Okay, length, okay, of this P1, okay, and then we print length of P1. So this one is, it is a static method, so we run it this way. Okay, we run it this way. Okay, we get this one. Okay, we get this one. So that's it. Now we actually can have another one. Okay, and another one. So here let's do define another function called len. Okay, this one let's do p as well. Okay, process the point. So this one will return this one. Let's actually do this. Okay, this is a length. Okay, now this length let's actually do get what? This one we do match the square root of this one. Okay. So let's try this one. Let's actually try. Let's make it double it. Okay, it doesn't make sense. Okay, it doesn't make sense. But I just want to show the difference. So this one we make it a function like this. Okay, and then here. Okay, and then here we do make it a class function. So we do have the len equals class methods. This guy len. Okay, so we make it a class method, and this one let's try it. Okay, so this one let's try len of the p1 equals location that len of p1. Okay, and here print len of the p1. Okay, so this one len of p1. Okay. So this one is the same thing. Okay, so here let's call this one this one. So the processing by the class method. This one. Okay, we get this one. So let's create another one called point 0 equals location 0, 0. Okay, so we have another point called point 0, and let's copy these two. Okay, copy these two. Okay, copy these two, and we put it over here. Okay, and here let's put P0, P0. Okay, P0. So here let's call it a static of the P0. This one static of the P1. Okay. This one let's put 2. Let's still put 2. Okay. And right here, let me actually copy this one. Okay. Let me copy this one. Okay, copy this one and put it over here. Okay. So this one let me put P0. P0. Okay. So let's put P0. This one class of the P0. This one class of the P0 again. P1 again. So these two actually, I say this 4 data is all the same. It's all the same. Let's see. 2 parameters are given. Okay. So here, let's see. Okay, P0. Okay, location. So here, I use a location to call that one. It doesn't go through. Okay, it uses a location to call that one. So static is okay. And when I use the location to call it, okay, I kind of having trouble to 2 are given. So it actually, it doesn't work. Okay, it doesn't work. It doesn't work because right here, I forget to put the CLS. Okay, you need to specify the class name. Okay, so that one. Okay, so that's safe. Okay, so that's actually you need to put a class name if you want to make it a class method. Okay, so that's that. And everything get the same data. Okay, same data. So your len function, either way you get the same result. Okay, you get the same result. So let me try to. Okay, so you get the same result. Okay, now let me actually right here. Okay, so right here I have a static method. Okay, so right here if I do define this leg function. Okay, copy this one, but I put it over here. Okay, so this one I put it leg function, but here I put 3. Okay, I put 3. Okay, 3 static one. Okay, static one. Okay, so this one let me make some multiplication. Okay, so here that's actually create this one as point. Okay, the point class. Okay, and this one we do use the point length. Okay, and this one we do use point class. Okay, okay, something like this. Okay, so now P0 is a parent class points class. Okay, so you call this a class function here. Okay, because the class will be supplied with the point class. Okay, and then P1 it override the definition of the len function, leg function. It triple it. Okay, and you will call different one. So let's look at this one. Here actually argument 1, 2 are given. Location leg. Location leg. So this one you do have the redefinition. Let's actually take out this one. Okay, let's take out this one. Okay, take out this one. Let's see here. We do have. We say that location take one position, but 2 are given. 2 are given. This one we have leg class. Okay, so let's try this one. Let's run it. Okay. So it has a redefinition, but P1 still get the double definition. Okay, P1 it actually still get a double definition here. Okay, you still get a double definition, and this one is a class. So it's subclass actually. This one apparently it doesn't inherit it. Okay, it doesn't override it. It doesn't actually override the definition from its parent class. Okay, it doesn't. Okay, apparently it doesn't. Okay, so here if we reclaiming it as a new class method. Okay, let's do this one. Okay, so I put here. Okay. Okay, it become 8. Okay, it become 8. Okay, so in this way we define this length function. Okay, we define this length function, and this one overriding is this one. Okay, so that's actually, can we put the static function also in the subclass? Let's copy. Okay, and put this static function over here. Can we redefine it by actually, can we redefine this function? Okay, we redefine it, and this one we just put a 0 there, so we actually will get a 0. We just want to see the difference. Okay, so only, okay, it got the 0, so you can you make it a redefinition. Okay, you make it a static function. Okay, so here if we don't have the redefinition, okay, we don't have a redefinition, then you will use its parent class definition. Okay, you will use the parent class definition. Okay, so that's that. That actually is the idea of the class function. Okay, and stated and the class method. Okay, these are okay. So let's look at the comparison between this static class method and the static method and the class method. Okay. So basically, class method, you will need to put the class name, and static, no, static, you don't need that, okay? And this one, you can call by class name the function, okay? And using this is also okay, okay? And this one, inheritance support, a definition is immutable function. You will override, but previous function is immutable, okay? This one is, the definition is immutable via inheritance, okay? You can override it, okay? You can override it, okay? This one means that immutable means that you cannot update the function. You cannot update function by using function factory. No, you cannot do that, okay? So object argument passing here, you actually do not need the CLS, okay, and do not need the cell. This one will need the CLS, okay, the class reference, okay. Okay, so that is that. Object, okay, object. Object class is the topmost class for Python, okay. In Python 2, you need to put the object in every object, in every class that you want to inherit the class. If you want to inherit the class, object class, okay, you need to put it into the inheritance list. Okay, so the inheritance list is just like what we did here, okay. You extend the point class, location extend the point class, so you need to put the base class over here, okay. You need to put the base class over there. But in Python 3, it's no longer needed, okay. Python 3, everybody, if you don't declare it, it will automatically inherit the object class, okay. So somewhat more similar to Java, okay. So object class is the topmost class, okay. So everybody, including integer, module, or list, they all inherit the object class, okay. So 2015 is an integer. System is one kind of the module. So these are instance. 1 and 1, this is a instance, okay. So class type class is actually a subclass of the object class as well, okay. Here, okay, this actually is the object class is the topmost class, okay. So you can inspect your object using the dir, and dir will show you the data field you have, okay. It will show you the data field you have. We show you already. So there's a default constructor called init, okay. And then you cannot override, you can override your init. So every class can override init, but you can also call your parents class by using super, okay, and then underline init, okay. You will call the super. So you do not inherit the function. You will inherit the function init, okay, from the object class. If you do not do anything, you inherit. In Java, the constructor is not inherited, okay. So here you do have the inheritance of the init function from your object class, okay. So it's a slightly different, but usually you can write your own to update it, okay. Same thing for init and str, okay. This actually are defined in your superclass, and object will have this definition. So this different underline function, we call it matrix function. sometimes we also call it D under function, double under function. So double underline init. Okay. And remember the init function in Python, we will inherit from the object. Okay. And in you can override it. And in Java, it's different case. Okay, Java you cannot inherit the constructor. Okay, no. So here, other property you have the init string. Okay, class you will return your class information. Okay, and then you have equals override equals. So here, let's see. Here we do have this different function. So have a point. We do have a point. Okay, if we do have a point, and we do have these two classes. So that's actually kind of put it here. Okay, let's try to use a decorate 3.py. Okay, so right here we are going to copy from decorate 2 for the two class definition. Okay, two class definition. So copy them here. Okay, and put it over here. Okay. Put it over here. So now we what we want to do is we will override the toString function. Okay, we do override the toString function. So let's also override the definition of the equal. Okay, equal will override the definition of the equality check. Okay, so this one you inspect current object with other object. Okay, with other object. So this other object you will compare with it as well. So this one we will check. Okay, we will return self.x equals other.x. Okay, and self.y equals other.y. Okay, so here we have equals. Okay, we have equals. So now let me copy the point over as well. Okay, so let's copy this 2 point. Okay, 2 point. Put it into here. So what is point? What's location? But the function defined in the point class. So location will also get it. Okay, location will also get it. So here we will do 0.0, 0.1 equals 0.0 is okay. So let's do 0.1 equals 0.0. Okay, you check its x and y value. Okay, and we use the so-called using the location object to compare with the point object. So because your location function also has a definition getting from the base class, so the equality is true. Okay, let's actually do the other way around. Okay, do the other way around. We do using here, let's do 0.0 compared to 0.1. Okay. They will be the same because both has a definition of the equality check. Okay. Both has the equality definition for the equality check. So that's for the equal. So add would be adding, overriding the plus sign. Okay. Iterator, and next we explained it already. Okay, you make your object iterable. Okay, so here we do have a basic definition. So there is also a len and a dictionary. Dictionary is a variable. Okay, that contain the dictionary for the objects, the so-called attributes. So here, let's try this one. Let's try print. Okay, print. Okay. This one is print out. Dictionary is not a function. Dictionary is a variable. Underline is a private variable. Okay, it is a private variable, and you do show this dictionary value. Okay, it will show you the property, the S and Y didn't show. Okay, so this one, let's actually try one more. Okay, copy this one and then we do print the P1's dictionary. Okay. Okay, and then let's go with we get the same thing. Okay, we get the same thing. So that's a dictionary. So here are some other more underlying and important double under function or property that you can look at. Okay, the double function property. So these are the important functions that you inherit from your object class. So toString is also similar to Java. Okay, equals we explained it already. Compare is from comparable interface, but you can use compare for it. Okay, iterator you have this iterator, delete you have finalize. Okay, so these are the comparisons between the important function that you inherit from the superclass, object class, or comparable interface. Okay. Decorator. Okay, this one is decorator. Decorator, we are going to teach you the decorator function. So first one, we need to know about the function factory. So right here, before we go into more serious discussion, right here, let's actually look at some effects. So this one is the decorator 3. So let's actually create someone called decorate, okay, for.py, okay. So I create that. I'm going to copy also the point and functions. Okay, let's copy this function to here. Okay. And before we go any further, okay, so that here, let's look at one function, okay, one function. So here, let's assume that I'm going to create a data, okay. So here, let's assume here I have a function, okay. I have a function. So here, let's see, we have a function, okay. Here, let's do this one. Let's do. So here, if I have a function called text function, okay, this text function will get some open and close text, okay, close text, two text, okay, two text I'm getting, okay, two text I'm getting, and then I'm going to actually get some function, okay, some function, and I have this one, okay, this one. So let's look at the function first, okay, the function. So here I have define a function f, a function, okay, function, okay. So this function here, I will have some message, okay. So this message, function of the message, this one I will return what? The string message, okay. I'm going to return the string message, okay. So right here, okay, let me see, define function. So here, let me use a pass, okay, so they will not have the problem. So now I actually have this function, okay. I have this f function, but I'm going to decorate it. So what I'm going to do is that this function, let me see, okay, let me try this one. I will return a message. So this function, we put a message, okay. This is a function, we input a message, and it will also return the message, okay. So right now I'm using the text function. So text function will modify this function, okay, will modify this function. That function to create a text, okay, open and close text, okay. So we'll actually modify. So here, let me choose it as make the parameter as text name, okay. Don't use message, use text name, okay, text name. So right here, I take this a function input, okay. So eventually, I'm going to return a new function, okay. So let me call it new f, okay. So new f will be returned, and we define this new function, okay, as such, okay. So this new function will actually, this one new function will get the text, okay, get the text okay, get a text, okay. So this new function will accept two parameters, open tag and close tag, okay. And then you will return, okay, you will actually, this one, you will accept the message as well, okay. So accept the tag name, okay, you accept tag name, okay. And the function f being input and function being input, okay, function being input. So you take in the tag name, okay, and this one you will do open tag, okay, plus the so-called function f, okay, and you will pass the tag name, and then would be it is close tag. So basically, open tag will be put here, close tag will be put here. And then this new function will call the old function with the parameter tag name. So you pass the tag name to the function func, okay? And that's the way we do tag, okay? That's the way we do tag, okay? So here, let's try this one, okay? Try make tag, okay? So make tag will be actually equals the tag function putting in func, okay? Putting in this function, so function as an input, okay? It will pass to this pass this tag function. So tag function take the function func, and then create a new function, and create a new function. The new function will be returned to make tag, okay? And then and then when we call it, okay, so call it okay, so here paragraph, okay, will be equals make tag, okay. Make tag, so make tag is a function that you get it here, so it has 3 parameters. So that's if you put that 3 parameter in, that will be a paragraph tag name and a open tag and closing tag. Passing this 3 over here, you pass to this new function's parameter, okay, and will return such a string. So after that, we do print out our paragraph of the text, okay. And let's save, save this one, and that's wrong. So you print out a P, okay. So this one is what? A wrapping function, okay. You wrap the old function with some extra thing, okay. So this tag function is a function factory, function generator, okay. You input a function and create a new function, and that new function takes 3 parameters in, okay. The old function takes only 1 parameter, but old function being called inside the new function, okay. So that's that. We may take, okay, we may take in this way. So we can actually also do the so-called division tag, okay. So division tag will be equals tag, okay, of the div, the open and close over here, okay, and then you put in the div, okay. So that's that. Okay, that's wrong. Okay, so that's the division tag. Okay, now let's go back to my point. Okay, my point here I have x and y. Okay, so here let me create another function. Okay, we do have a length, whatever. I don't care about it now. So here let me have a function. So define coordinate function. So this coordinate function, we do have self. Okay, and this one will return the self that x plus comma, okay, and then plus self y. Okay, so these two are not string, so we need to convert the integer to string. Okay, to make it a string. Okay, so we convert it in this way. That's actually coordinate. But somehow this one is in 3, 2 format. Okay, or we don't have parentheses. We don't have parentheses. Or 2, 2 way. Okay. Now I really want to add the 10 before and after it. Okay. So what my purpose is that this coordinate function, I will create another one. Okay, I'll create another one. So this coordinate function will be equals my take function. Okay, and then put the coordinate function in. Okay, put in the coordinate function in here. Okay. Okay. So this one, let's try this one. Okay, we do have a function and we multiply the coordinate function. Okay, so right now we do has that. Okay, we do have that, and actually is a coordinate function. Okay, and then the coordinate function now would take 2 parameters. So here, let's define a different function. Okay. Let's actually define a different function. So this one may not work because it has a parameter of cell. Okay, it has a parameter of cell. Okay, so here we do need to change it a little bit. Okay, so this one, let's try this one. Let's try another one. Define. Okay, actually parenthesis function. Okay, so parenthesis function will multiply a function. We define a new function. Okay, this new function, and eventually we will return the new function. Okay, eventually we'll return the new function. Okay, so now the function we take actually is what? The function we take is this the so-called coordinate function. Okay, the so-called coordinate function, and coordinate function do have a first parameter cell. Okay, so this one I must take a variable called cell. Okay, must actually call cell. Okay, so cell function we get that. Okay, so this one will return. Okay, and then we should have a okay, open tag and close tag. Okay, so we need to have these two as well. Okay, so this one I'm going to copy from here. Okay, so copy from here, put it into here. Okay, so it still pass a function, and we actually will pass the cell to it. Okay, the first parameter cell will be copied to it. So let's look at this one. Okay, original function is coordinate. You take a parameter called cell into it. Okay, now this coordinate function without a cell, okay, without a cell, being passed to this one called parenthesis function. Okay, so this parenthesis function you generate a new function NF, and this new f, okay, this new f will call this one called what? Cell. Okay, for example, with the cell. Okay, and then open tag. Okay, and close tag. Okay, open tag and close tag. So we'll create a new function that make the parameter with the older function. Okay, so this one coordinate function we will actually do coordinate function equals parenthesis function of my coordinate function. Okay, and then passing cell to it. Okay, no, I'm sorry, this one. Okay, that would be good. Okay, that would be my function. So that would be my coordinate function. Okay, That would be my coordinate function. So here, let's do this one. Okay. We have a coordinate function. So here we should have a CO. Okay. CO of the P0 should be equals the P0 that coordinate function, and then self is passed. So here I'm going to pass the parentheses and this parentheses there. Okay. And this one I'm going to do print my COP0. Okay. That one we save and then it run. Okay. We have one more extra parenthesis. Let me delete it. Okay. Unnecessary parenthesis. Save and that's wrong. Okay, and we do get 2. Okay, but this one we still want to hide our parentheses. We don't want to every time call this one. Okay, we do not want to every time call this one. That actually too tedious. Okay, that actually is too tedious. We don't want to do that. Okay. So here, let's do this one. Okay, we have a function. We multiply the coordinate function. So let's do definition display function. Display function. So display function will pass the self function into there. Okay, and this one will return the self that coordinate function. Okay, and this coordinate function will pass the self as the first parameter, and then there's open tab and close tab. Okay, so that would be easier. And this one we do use actually display P0 equals P0. Okay, and that display. And then we do print now my display P0. Okay, then that will automatically print out the same 2. Okay, so that is to do using the wrapping function to actually use the wrap function to repeat the self function. So here, first I use the make example to wrap up my tag. Okay, wrap up my tag. Okay, wrap up my tag to make tag. And later I use the similar function to add the parentheses in there. Okay, so this one's decorated for. That's actually called another function, decorate by the py. Okay. So I'm going to copy this one again, everything from here to the end. Okay, to the end. So this 0.1, 0.2 will still be there. Okay, so let's copy, go to here. Okay, and we already finished the demonstration for tag and function. So these 2 I'm going to take out. I don't need it. I need to have the parenthesis function there. Okay, so now this one a little bit too complicated. Okay, a little bit too complicated. So we have this function and we wrap up the function with parentheses. Okay, with parentheses. So here we do use this one. So and here we will be using the decorator. So at parent, we do this. And this one can be taken out. Okay. Okay, this one can be taken out. So right here, this one we have a static method. So this one right here, we do add static method, okay, and this one can be taken out, okay. This one can be taken out, okay. So this one is a class method. So right here we do add class method, okay. So this decorator is a function generator. It modifies the origin function with the generator functions. Okay, the function factory function. Okay, and you pass the coordinate multiplied by it, you return. Okay, so something like that. These are all we needed. So right here, this one we will also use it as method. Okay, and we finish this one. So now we actually, because we have these different method, we have 0.1, 0.2 different things. Okay, so let's go to this one. Okay, 0.2. Okay, so let's go to 0.2. Let's copy the whole function we are testing over here. Put to here, okay, because we are going to run the same testing. So we put it over here, okay. And then 3, we are checking the equality. Let's still copy it, okay. So 2, 3, function 4, okay. We all put it, okay. So here, here, okay. So right here, let's print, okay, print, okay. So from 2. Let's actually copy, okay, copy this one, put it over here. We call it from decorate 3, okay, and we go to the decorate 4. Decorate 4 method, we don't do it, okay, we don't do it. We actually start it from this parenthesis portion. So copy this one, put it over here. And then this portion, we actually do measure from decorate 4, okay, decorate 4. Here, in between the measures, we do use print to separate it, okay. Okay, good enough. Let's actually save them, and let's run the code. So everything just worked out fine, okay? So that's the power of using decorator. So decorator is a function generator. So you had a parenthesis, and your input function will be multiplied, okay? Input function will be multiplied by the new function. But you can assign the new function back to f function. So that is the way we use the decorator. Okay, so decorator is a wrapper. Okay, it's a wrapper. It actually is also a generator of the new function, and the new function can be assigned to the old function. So in this way, we decorate this coordinate function by using this new function generator with adding toTag to the original function's result. Okay, to the original function result, and the original function result is getting the 2 point, the x and y data, and we actually wrap them with toTag. Okay, with toTag, and so we call this one, you get this, but because we don't want to see the parentheses when we call it, so we add another one with this display. Okay, with this display. So, okay, so this one is okay. Okay, so that one is okay. So this one is the way we use the decorator function. Okay, the way we use the decorator function. So class function can be wrapped by using the decorator. Okay, and it will become a class function. Same thing for static function, and we can also have property function. Okay, so property function is to make a function like a data field. Okay, property function is actually to make a function like a proper data field. So here, let's do this one. Okay, let's do this one. Let's try to define a function. So here we may define a function. Okay, this function is called square. Okay. Square distance. Okay. So square distance function, let's actually do self. Okay, we get a self function that's actually square distance function. The definition is here. Okay, definition is that we go from point 1 to point 2. We do go this way. That's the square root of x delta x squared plus delta y squared, right? But we can also use the delta x plus delta y if we don't only allow to go in right angles, okay? So that one is assume that this is called square distance, okay, square distance. Okay, this is a function called square distance. That's actually called square distance from origin. Okay, square distance from origin. So this one will actually do return, okay, self.x plus self.y. Okay, we'll return this thing. Okay, but we want to make it as a property. So make it as a property. Okay, so this one is become a derived data figure. Okay, become a derived data figure. So by adding this, we can do here. Okay, so let's copy these two. Okay, copy these two. Take away 5. Okay, so that's do print. Okay, print what? Print my P0 dot. Okay, that's the distance from. That's the distance from the origin. Okay. Okay, 2, 2, you get 4. Okay, so that's the definition of the property decorator. Property decorator is to make your current function as a data field. Okay. Okay, that's actually its property. Okay. And okay, this is a class method. We don't go into there anymore. Okay, so you know you can read it. Okay, you can read it. So this portion we just skip it. Okay, the static function and class, we have enough discussion for that. Okay, you can read through this different one. Then you can make some function as attribute setter. Okay, so there's an attribute. You do attribute setter. You modify the setter function for that one. Okay, so let's try this one, attribute that setter. Okay, so let's assume that we want to set certain attribute. Okay, so we have x and y. So let's try this one. Okay, let's try this one. Okay, the attribute will get some value. Okay, some value. This one's attribute setter. Okay, and has some value, and attribute editor. Okay, so here let's see. So here we have the attribute setter. We can accept the value like a left-hand side value. Okay, accept the value like a left-hand side value, and we assign it to some attribute. Okay, so attribute. Okay, this one is what we have the attribute. Okay, so the attribute we can also create a pair of setter and a getter to modify the function. Okay, modify the data field. So you can modify the data field, but in this case, we do not have example for it. Okay, so that's okay. This one, let's just go. So override object methods. Overloading or overriding the object methods. Okay. So overriding object methods. Okay, so the object class has many the double underscore function. We call it private functions. Okay, and then these private functions can be overridden. Okay, by user definition. So you can change the add function for the plus sign. You can change the string function for you to convert the object to string or representation. Okay, we talked about this already. So let's assume that we have a length function, and we can actually, this length, we can override the constructor, override the add function. So add function can add two lengths. okay, two-length object, and we override the plus sign, okay, we override the plus sign. Okay, so when we print a object, you will call the string function, okay, and we can also override the reprint function, okay, representation function using this, okay, so the overridden of the magic function. Okay, so here are several different functions you can override. Okay, these are all the magic functions. Add, sub, multiply. Okay, for division. This one is integer division. Okay, true division is a real number division. And math, power, left shift, right shift. Okay, it's different function. Same thing, the augmented assignment. Okay, so I don't go into the details. And there is a augmented assignment. Okay. Every one of the augmented assignment, they have an I in front of it, okay? Incremental, okay, incremental. So I function. And here we can change the negation, positive, absolute value, invert, okay, complex, okay, it's different function as well, okay? Comparators, okay. So equal is one of the comparison operators, okay? These are called magic functions. A magic function are default function that given by the object class. So when you inherit the object class, you do have it, and you can override them. Okay, you can override them. And we have the new for the constructor, init for the new for construction. Okay, and init function and delete. Okay, so customize and initial deletion. So this one is you can customize it. We don't go into the detail. Okay, so this one. For comparison, you can update it, okay, and you can look at different magic function. So get item is used to what? Get item is used for array to using array format, okay. If you put an index in here and your array A, you should be able to get certain item with that value. If you override it, set item, you set the make this A of I can be accept some value. So these two are important when you use containers. Okay. So get item and set item are very important. Okay. And other than that, you can study by yourself. Okay. So this is the end of the chapter 5A. Chapter 5A, we work on the definition of the class design. Okay. So we talk about what is class and how to use class, okay? And in using of the class, we talk about what is data field, what are the functions, and we also talking about how to override the default function from the object class. And these are important design issues for a class, okay? Thank you. See you next time for the second part, chapter 5B, on the class-to-class relationship. Okay, bye-bye.